Okay, 43 is almost the same problem as 41, except that time is now the independent variable instead of x. And that's why the graph starts at t equals 0, because we don't want to talk about negative time. This is t equals 0, and y equals f of x, and that's the position function of the car. So I've already drawn in this case, c is the simplest looking function, and that's a good bet, as I said, for f of x. So it looks like the car started out at position 0 at time equals 0, and it gradually went forward along y, in the y direction, and its maximum rate of change was somewhere in here. And then it started slowing down again, and it kind of came to rest here somewhere. So it looks to me like the velocity, which is, let's say v equals dy dt equals f prime of x. It looks to me like the velocity was a maximum here. It was 0 when time equals 0. So the velocity kind of went up here. And again, I don't see that the velocity is ever negative. So it kind of goes up here, and then it gradually goes down towards t, where t is sort of the asymptote. Okay, what does that look like? Well, that looks like the graph B. And again, my scale is not very good here, but close enough. We can say B certainly looks like the velocity. Now acceleration equals dv dt, which is the second derivative of the position, which we can write as d squared y over dt squared equals f double prime of x. And the acceleration is the tangent line of the velocity. So notice that the velocity, or the change in the velocity, is 0 at the maximum velocity, and it starts to become negative here. So the acceleration is 0 at this point, t. So at whatever this number is, that's where the acceleration goes to 0, and the maximum rate of change of the velocity is right around here. So the acceleration has to look like this. Goes up, reaches its maximum here, and then comes back down and gets to 0 right here, where the change in velocity levels off. So what's happening to the velocity here? It's going down, so it's in the negative range. So it's going to come down. And maybe, let's say, the maximum decrease in velocity is here. So that's where the minimum negative acceleration is. So this is deceleration, is another way we would speak of this. This is deceleration, or negative acceleration. And the deceleration reaches a minimum here, and then it comes back up towards 0, because as the velocity stops changing, the acceleration stops changing. And so this looks kind of like A.